Hello, and welcome to today's webinar on joint activity design heuristics with Dr. Dane Morey and Dr. Michael Rayo. I'm your moderator, Dr. Laura McGuire, and I am a research scientist with the Cognitive Systems Engineering Lab, and I lead the Resilience and Proactive Safety Initiative within our lab. The intent of the Resilience and Proactive Safety Initiative is really to merge theory with practice. We want to create more opportunities for our research to have tangible impacts within the domains and within the companies that we conduct our research within. So if you and your organization would like more information about upcoming webinars, training, or how to get involved with upcoming research opportunities, please take a minute to scan the QR code and sign up for our newsletter. In addition to working closely with industry, we work closely with a number of partner organizations that are all focused on advancing safety and human performance in high risk and high consequence industries. These are the Resilience Engineering Association, the Naturalistic Decision Making Association, and the Cognitive Engineering and Decision Making Technical Group. So we look forward to this being an interactive session. You can use the question and answer feature, of course, to ask any questions, and use the chat feature to interact with each other, as well as to make any comments on the content as we run through the session. So today our speakers are Dr. Dane Morey, who is a research scientist with the Cognitive Systems Engineering Laboratory, and his research has focused on the design and evaluation strategies that facilitate resilient human-machine performance, especially for AI-infused technologies. Our second speaker is Dr. Michael Rayo, and he's the director of the Cognitive Systems Engineering Laboratory. He has worked with NASA, the Air Force, and NSF to design prototypes of high-performing teams, human-machine teaming architecture for high uncertainty, high complexity, and safety-critical settings. I'll turn it over to our speakers.
And what we want to really figure, we're going to try to work into 4 different questions. First, what is joint activity? Second, why is it important? Third, why focus on the joint activity or JAD heuristics? And then fourth, and that's probably what you are all here, that's probably what you're all waiting for, what are those JAD heuristics? I wanted to, before we answer those questions, I did have one more question for you, and it gets into how we really are interested in this being an interactive session. To that end, whoever is not talking amongst Laura, Dane, and me will be manning both the chat and the Q&A. And I'm going to actually get you acculturated to participating. And I'm going to ask my first question is, what city, state, and country are you here with, from, around, beside? Where are you calling from? So you can throw that in the chat. If you want to put it in the form of a question, I suppose you could also put it in the Q&A, but let's put it in the chat. While you all are putting that in there, where you're coming from, we'll be checking out that. I just want to see where everybody's coming from. So I'll get started.
Unfortunately, Mike, sorry, the chat has been disabled, so I'm working on enabling that right now.
Zoom hates us. It hates us. All right. Well, when we get back, when you get your chat, we'll do that. All right. So first, let's just get some definitions out. Let's get some language. Let's get some common grounding around this. First, joint activity. We're going to make it as simple as we can and as broad as we can here. It's a set of 2 or more agents working together to perform an activity. And when we say an activity, what we mean, again, let's just keep it real simple, something that is or has been done. Now, we do want to make a distinction here because we're going to draw from the French translation of activité. That's a really terrible French pronunciation, but it's the actual work that's being done, that work as done, not the formalized, often distorted view from afar of that work, which we've called work as imagined. And you'll notice that throughout this talk, we are going to be relying heavily on the language of cognitive systems engineering, on naturalistic decision making, and on resilience engineering. But hopefully, you know, if you don't have your translator for those, we're gonna do that translation for you. So that's what we're talking about with joint activity. Now, what we found really instructive in thinking about joint activity, because that's really broad, that's a whole lot of stuff. what we found really instructive is thinking about joint activity through the lens of what are called macrocognitive functions. Now, that's a mouthful. And so if you are an aficionado of macrocognitive functions, and I hope there are some of you out there, not only live, but when you catch the recording, and maybe you're an OG macrocognitive functioner and you know this diagram. Maybe you're a little bit more modern. You got that, the kind of multicolor version, this version. Maybe you're like an abstract thinker and you're into the Patterson-Hoffman version of this set of the macrocognitive functions. Or maybe you're kind of minimalist. This is probably the most skinny down, most simplified version of that. But let's make it a little bit more complicated. Because thinking about that really skinny it down to detecting, interpreting, and responding. Every single slide is going to be messed up too. That's fantastic. Um, so that idea of coordinating across agents and then actually thinking about those macrocognitive functions across what we call the perception action cycle. Regardless of how you know the macrocognitive functions, or maybe if you don't know the macrocognitive functions, really what we're talking about here is it's a description of the cognitive functions that are performed in natural, or dare I say, naturalistic versus artificial laboratory settings for decision making, in those decision making settings. And what we found, what our community has found in this case, is that macrocognitive functions are cognition across multiple heads. That's how cognition really happens. And so we're thinking about, as we're in these naturalistic settings, we're thinking about how is cognition happening across multiple heads, across multiple agents. All right, so we have macrocognitive functions. So why is joint activity important? Let me give you the short version first. And that is drawing from the work of Matt Johnson, Jeff Bradshaw, Paul Feltovich, Robert Hoffman, all of our friends at the Institute for Machine and Human Cognition down in Pensacola, with a lot of their colleagues at Delft. And this idea is you put all these things together, thinking about interdependence, thinking about teaming intelligence, thinking about coactive design. We have references at the end, but the big picture here is that interdependency, that is the notion that agents and their behaviors are dependent on the agents and their behaviors around them, interdependency should be assumed, which means that all work should be assumed to be joint, or don't work together unless proven otherwise. Now we can go fight about that later, but this is the central point or concept that we're going to be working on, that we're thinking about joint activity, we're thinking about jointness until proven otherwise. Now, if you're won over with that, great, you can go take a 3-minute walk, or just meditate for a couple minutes. But if you're not convinced yet, I have a slightly longer version of it that starts like this. What we really care about, and this is going all the way back to our central objective here at the lab, and what we think is really important, is we want to be designing for resilient performance. And when we talk about resilient performance, that is the ability to adapt in order to sustain essential goals, structures, and functions in the face of ever-growing dynamics and uncertainty. That adapt word is really, really, really important. And that adapt word basically expands into a notion of resilient performance called graceful extensibility, one of at least four of the most popular notions of resilient performance. That's the one we're going to really focus in on. And it just so happens that there's a theory of graceful extensibility. And that theory has 10 proto-theorems. And we're not going to talk about any of those proto-theorems in gory detail. In fact, we're really just going to focus, we're not going to talk about some of them at all, but we are going to talk about these. And with these, what we know from all of our experience and all of our research and all of our science here is that these units, and just think about a unit as being anything from a person to a team to an organization to maybe even as big as a country, they all risk saturation. They all get to the edge of their capability envelope, and they all require the ability to extend. No unit can manage that need, that risk of saturation alone, and has to coordinate with others. Neighboring units, can monitor and should monitor. And so that neighboring, again, can you see the jointness here that's required? All adaptive units are local and constrained by their position. There's no omniscient location, and all perspectives are limited. All of that points to the need for joint and jointness. So hopefully with both of those coordinated, we've got you, hooked in enough. And we say, okay, maybe joint really is the way. So now let's get into why heuristics. Like joint activity design is actually, we could focus on a lot of different things. And by the way, our lab has focused on a lot of different things. But why the heuristics? And so as we think about, all of the things that we've, and these three organizations, naturalistic decision may, or these three communities, not the organizations, but the communities, naturalistic decision making, resilience engineering, cognitive systems engineering, have been very productive. Maybe not as productive as we want them to be, but have been very productive over the last, pick the discipline, 20 to 40 years. So, and I'm going to just, to illustrate that, I'm going to put a number of things on this screen. It is not meant to be exhaustive. I may not put, one of your top hits on there, and if that happens, I'm sorry, it's probably going to happen. But just to illustrate that there's a lot of things that we put in the world, and arguably these three disciplines are as suited as anyone. Again, there are other ones that I don't have on here, but as suited as anyone to be able to help us work with those systems for resilient performance in the real world with safety critical industries. So on the NDM side, we have things, again, dual loop reasoning, recognition prime decision making, macrocognitive functions. As we get to RE, we have a number of different, not only techniques, but also some things, coming over here in cognitive systems engineering. We also have some things that are split across them: cognitive task analysis, cognitive work analysis. We have things that are shared between RE and CSE. Law of fluency is just one example of those things. And there are a number of other things that are not, maybe not textbook or canon, within either of those three disciplines, but also really important to systems engineering. I've just put a couple of those on here. Now, as we think about all of those different things and where can we make a difference, we started to map those across a solution development lifecycle. And this isn't perfect, again, not exhaustive, but you'll notice that there's a big gap in here. And that gap is around heuristics. And with heuristics, broadly speaking, we can think about that, or design heuristics specifically. Broadly speaking, say a heuristic is anything that's a rule of thumb. And maybe you all are firing up the chat and the Q&A right now saying, I know a heuristic, Rayo's being oversimplified. Certainly I am. But the kind of heuristic that I'm thinking about are actually the kind of heuristic that have been very, very successful in UX, UI, HCI, UCD, that user-centered experience kind of stuff. That are kind of, they're ready to go. They're easily remembered. They're as focused as possible. Put them in the hands of the designers. And so obviously there's a question here. Do the usability heuristics, do they fill in that space? We have all of these other things that are certainly ready to go. In all of these other different, these different columns from discovery and analysis through guidelines, patterns, and then on forward with development, evaluation, and deployment, which, by the way, we have lots of stuff to talk about there too, but we're not going to talk about that today. And the question is, do usability heuristics, that's what I'm talking about. That's the style of thing I'm talking about. We don't really have that in those three disciplines. Could we just borrow the usability heuristics? And so the question we've been asking, we haven't brought up this AI word just yet, but let's bring it up now. The question we've been asking as we were thinking about these joint activity design heuristics is the human-centered design community ready for AI-infused technologies? And to help us answer that, I'm going to turn it over to Dane.
Perfect. Thanks, Mike. So we're talking about, and AI is the hot button topic right now in trying to address whether or not these kind of these heuristics that the design community is already using, tried and true heuristics that they're already using. One of the things, actually, I'll come back to this a little bit later, but I want to focus on one set of heuristics that's pretty well known throughout, especially the usability UI UX community. These ones come from Jacob Nielsen, 10 usability heuristics for interface design, and we could spend an entire hour-long webinar kind of talking about all these different ways and how they map to different aspects of joint activity. But for now, I want to focus on just one in particular, and that is recognition rather than recall. And that let's see if I can get this to go. There we go. So recognition rather than recall, one of the 10 usability heuristics from Nielsen specifies that we should be trying in our designs to minimize users' memory load by making elements, actions, and options visible. Basically, anything that you could put on the screen, put on the screen. Don't make users have to remember stuff when you can put it on the screen. And so as we think about designing AI agents, AI-infused technologies, it's pretty easy to see how we might be able to apply this heuristic and why recognition is probably a better design strategy than recall. Here's a little simple example. I have a cartoon robot there. Maybe that robot asks me something like, "What is the capital of Portugal?" And to the disappointment of my grade school geography teacher, I may be stuck scratching my head, unable to remember what's the capital of Portugal. But instead, if that AI robot instead rephrase that question to ask, "Is Lisbon the capital of Portugal?" I may be able to very quickly recognize, yes, yes, that's right, Lisbon is the capital of Portugal. And so it's pretty easy to see how recognizing a solution rather than having to recall it is a pretty effective strategy here. And we can imagine very easily how this can scale, and allow us to do more efficient, more work more efficiently. It's like, maybe is Istanbul the capital of Turkey? Is Auckland the capital of New Zealand? And I can go yes, 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 all the way down the list. I'm faster, I'm better, and that's all well and good, except for the fact that all of these are wrong. So Istanbul is not the capital of Turkey. It's Ankara. Wellington is actually the capital of New Zealand, and so on and so on and so on. And what we find when we're dealing with these AI infused technologies that are able to make recommendations is that when that recommendation is wrong, is erroneous, is misleading, people are actually substantially more likely to kind of come to that same conclusion as that AI recommendation. So sort of flies in the face of this normal usability heuristic. Recognition might actually increase the extent to which wrong recommendations from the machine are negatively impactful. Just for fun, let's look at one other example on these 10 usability heuristics here. I'll highlight here consistency and standards. And the way that one reads is users should not have to wonder whether different words, situations, or actions mean the same thing. We should follow industry standards and conventions and expectations. And of course, certainly on the face, that seems like a thing that absolutely all designs across the board should do. What you're looking at right here is actually one of our prior experimental designs. This is a prototype interface for a bedside nurse or a central monitoring nurse to remotely monitor a patient's vitals and anticipate patient decompensation earlier. And one of the things, in the spirit of kind of consistency and standards, there is a lot of stuff on this display. Some of it comes from an AI algorithm over here on the left. Some of it's kind of raw patient data. Some of it's actually other technologies in the hospital, like alarms. And so one of the things we tried to do, again, applying our usability heuristics, is we wanted to kind of increase the coherency across this display by using the color red red especially, to draw attention to areas of the display that were that we thought would be concerning to a nurse. And one of the unexpected consequences of using this usability heuristic is actually we found that nurses substantially confused what was AI and what was just kind of other parts of the data display. So nurses both thought or both correctly thought that things that were on the display that were red were part of the AI algorithm, and other things that we kind of inadvertently had tried to draw attention to, nurses were substantially more likely to attribute those aspects of the display to the AI. So we see this kind of like this sort of tension between creating a coherent, consistent display and conflicting with this ability to sort of separate and differentiate what are the AI algorithm components of this display, or to what extent does the AI is the AI able to access information on the display from other things that maybe are not accessible to the AI algorithm. And like I said, we could go on and on and on and have a whole hour-long session sort of digging into usability heuristics. But I want to pull back and kind of ask, why might usability heuristics alone not be sufficient for designing AI-infused technologies? And I want to pull us back to the perception action cycle. So we're constantly in this feedback loop of perceiving our environment and acting on that environment. That general perception action cycle. There are probably a half dozen different varieties of this. We've created a fairly simplified one here. But just the general notion that there's some degree people are detecting some things from the world, interpreting those things, and then responding to the world in some way. And what we find, or what we'll assert today, is that what we find is usability, things like usability heuristics or UI UX design principles or human-centered design principles or human-computer interaction are, for the most part, predominantly focused on this responding portion of the perception action cycle. That may be a little bit unfair in some circumstances, but we find on the whole, most of these usability heuristics that we just covered are interested in or are focused on how do people effectively respond through the display to take actions through the display. And so what we'll talk to you about for the rest of this webinar today, what we'll talk to you about is taking a broader perspective. The idea with joint activity design is to more broadly consider the full world, the full scope of the perception action cycle, not just responding, but also detecting and interpreting as well. And as we expand to this kind of broader world of the perception action cycle, what we find is that the list of considerations kind of explodes, right? So I've pulled out a number here. This is probably a grossly inadequate list, but these are a number of macrocognitive challenges that are grouped under macrocognitive functions, and I've kind of generally organized them around the perception action cycle here. So we have a number of kind of problems or considerations that are related to detecting events and sense making and planning and deciding. And again, this world gets really complicated really quick as we expand the scope of our system to sort of the full perception action cycle. And with that, I'll actually throw it back over to my partner here for the next portion.
And I will hit the wrong button. 1 second, everybody. So let's try that again. There we go. Okay, so we've talked about what joint activity is, what the joint activity heuristics are in general. We haven't gotten into the details, which we will be. And any moment now, we're going to get there, I promise. But as if you're hearing this idea of joint activity, you may be thinking about, you'd be tempted to think about, and I wouldn't blame you if you did. You think, hey, I've heard something about that. Aren't you just talking about human machine teaming? Or maybe like, oh wait, I've heard something about that, but we're just talking about, you know, this technology. It's just a fancy tool, right? And that's actually that is a conversation, a spirited conversation that's happening throughout a number of our disciplines, a number of our communities right now. This idea of technology as teammate and technology as super tool. I'm not going to get into naming names, but there are a lot of folks that are very accomplished, that are sitting on one side or another of this fence. And you notice that this particular webinar is not titled Heuristics for Technology as Teammate or Heuristics for Technology as Super Tool. And the reason that is because we think both of these are limited, and they have actually meaningful limitations. Technology as teammate, and when I'm just going over the kind of top ones, the first one is there's this tendency to anthropomorphize any technology. If you think of it as a teammate, we have this idea of it's a human teammate. Now we can certainly get over that. But the other one is maybe more important, is this idea of scope narrowing. Oh, what's a team or what's not a team? And are there forms of jointness that go larger than team, whether in time or in space? On the super tool side, we have what I call interdependence blindness. That, oh, it's just a tool. Oh, it's just, I use it. It doesn't, it doesn't influence me. There's those forms of interdependence blindness. And there's also what I call hammer envy. And again, it's this idea that, oh, it's a tool, and I have a design process to design a tool, and so I'm going to do the same thing, the same kind of process with these much more capable technologies. Now, in addition to those, perhaps the most important one is this: both of them has the potential, it's not absolute, but the potential to obstruct our ability to describe the system functionally. Activity is a verb. Teammate, super tool, they are nouns. And so as we think about, the biggest limitation here is that too many nouns, not enough verbs. So if we focus on the verbs, we can actually start to elaborate about how they're working together. What are the actions and activities that they're taking? Is it as a teammate or not a teammate or not? Kind of not important. Is it a super tool or a tool? Or, again, kind of not important. How are they architected to work together? How are they intended to work together? How is it emergent that they actually work together? Again, just, in disparate, distributed in time and space.
Mike, I'm just going to jump in. You're in presenter view right now. Do you want to just hop over to the
Sure.
presentation mode?
Thank you so much. Better?
Not quite. Not yet.
Okay, I swapped the displays. Again, so when I hit swap displays, it's not doing anything?
No, we're still seeing it as presenter mode.
Okay, here we go. Let's try it again. So put all that together, and we believe that we need new design heuristics for supporting joint activity, and to go through them in an increasing but not quite gory detail. Back to Dane.
Yeah, thanks. I'm gonna again. This is like it's gonna feel woefully inadequate, the amount of time we have right now. We could speak on this for hours and hours and hours, but I'm gonna try to give a quick overview with a few examples. And please just know we have a lot more details. We'd love to share them with not only you but the whole but the world. But I'll try to give a quick overview here today and leave some time for questions at the end. First, I wanted to really quickly lay some groundwork here. A couple base assumptions that we're going into these joint activity design heuristics with. And one, it's that the machine, the technology we're designing is not meant to replace people, but rather to augment, assist, work with. We're talking about joint activity, not replacing activity, right? And because of that, obviously the machine will need to interact with people. The machine shouldn't be something that is invisible or separate or invisible to people as well. So here, we've iterated a few times here. Here is our most recent current list of joint activity design heuristics. We're up to 14, not that the number matters at all, but we've grouped them into, you'll notice that we've grouped them into 5 categories here, or 5 groupings. And they should seem somewhat familiar, at least vaguely familiar to some common or to some of your favorite macrocognitive functions as well. So we've used kind of macrocognitive functions as a generalized framework for organizing these design heuristics, and you see here, and especially emphasizing the jointness of each of these macrocognitive functions. We have a joint event detection, joint sense making, supporting human adaptability throughout this joint activity, joint perspective shifting, and this last category of human machine coordination. So in the next in the time we have left, I'm going to go through. I'll flash up some or our kind of high level description of each of these heuristics. And again, there's tons and tons of details that we don't have time to get into today. But I'll flash up each of these high level descriptions and give a kind of a brief example of maybe some designs that are good examples of these joint activity design heuristics, and some that maybe not so good examples. So in joint event detection, we have 2 heuristics that we found that we recommend and have emerged from kind of the larger literature, from naturalistic decision making, cognitive systems engineering, resilience engineering. And first, different signals need to be identifiable and distinguishable, not just under normal operations, but also in noisy and overcrowded environments. So we need to design our signals in order to be detected even when your display interface is overloaded with noisy and crowded other signals that may be competing for attention. And somewhat related to that is the need to organize data to be able to form emergent patterns. The data should be, the organization of the data themselves should be so that these kind of larger patterns or patterns of different kinds of events sort of emerge from the display itself. And so to give you an example here, actually, Mike and I, in the early days of the pandemic, we volunteered some of our time to assist the Ohio Department of Health in part, and actually Ohio State as well, in sort of advising some of the or in advising and trying to assist both the state of Ohio and the university with how they were interpreting and reacting to the ongoing COVID-19 pandemic. This was the public-facing interface that the public of the state of Ohio was shown. And I want to focus on a couple things on this interface here, especially on this left-hand side of the graph. So at the end of the day, there's this graph. Each of those polygons represents a county within the state of Ohio, and each of those counties were color-coded with 4 different categories that were supposed to indicate kind of the degree of risk here. And a couple things that were sort of hidden in this categorization is that both the prevalence of COVID-19 infections and the trend, and actually several other factors, were hidden or obscured behind a pretty complicated aggregation that had a number of kind of weird and quirky rules to it. And because of these kind of weird and quirky rules that led to this aggregation, what appears to be some, a pretty obvious regional trends here. It looks like the northeast corner of Ohio is kind of more consistently red than, say, for example, the southwest corner of Ohio. But because of these weird kind of quirky aggregations, it could actually produce some misleading trends, regional trends. And so that was design A that I provide design A. Here's a different design that we actually built here at Ohio State. And what you're looking at here is actually a trend graph for each county in Ohio. And what you'll notice here is that both the kind of overall prevalence of the disease and its short-term trend over the last 21 days are encoded in these in these kind of little miniature graphs. And we intentionally tried to make these graphs show different sorts of shapes to support the recognition of different kinds of events or trends. And what we also did, if you're not familiar with Ohio, these graphs are also generally organized with the geography of Ohio in mind to sort of preserve those regional trends. So again, I'm going to breeze through these because I want to get through all these heuristics and leave some time at the end for questions. As we move into joint sense making, we have two heuristics that we've specified for joint sense making. The first is that the dimensions of a display or an interface should match the real world complexity and uncertainty that is present in the real world. And the second one might sound simple, but certainly worth mentioning, is that display should present information in context of past information, future expectations, or other information that may influence how that data should be interpreted in the specific situation. So same example here. Actually, this is another one of our previous displays from a little while back here. Certainly not quite as pretty as the previous one, but bear with me here. I know, yeah, Mike's laughing at that one. But one of the really one of the really interesting things is yeah, what you're seeing here is this is several different data sources of a patient's vitals. We won't get into the details here, but we have heart rate on the bottom, pulse ox on the top, some blood pressure readings in the middle here. And what we see annotated on these graphs are actually clinical alarms. And what we found is that literally simply kind of smashing on top when these clinical alarms happened in the context of what those data readings were actually helped nurses detect hazardous events far more accurately than the clinical alarms themselves. So again, not necessarily the prettiest display out there, but a simple, surprising, effective technique that just simply putting these two data sets, clinical alarms and the data with which the alarms are based on, in context of each other, drastically improved joint sense making for nurses here. All right, continuing the whirlwind tour through the design heuristics here. Next grouping is supporting human adaptability in joint activity. We have three heuristics here. One, number 5. We believe that technologies should be as minimally assertive as possible, as we can get away with, to avoid the dangers of potentially misleading disruptions. So any kind of interjection, assertion, or interruption from a machine has the potential to negatively impact work. And so we believe that technology should be designed to be as minimally assertive as possible. Number 6 here, again, might sound obvious, but still worth mentioning. Technology should be designed to defer to people. So since people are responsible for systems outputs, people have to be able to take full control of the system. Again, might sound obvious, but certainly worth noting, especially in light of some technology trends. And finally, the last one here, I'll touch on it briefly here. But part of supporting human adaptability is supporting people's ability to modulate or adjust the degree to which they are involved or engaged with the automated system. And the kind of degree of engagement may vary as a function of a variety of different things. For example, different tempos of operations. In fast-paced operations, where I need to make a decision now, I shouldn't be having to kind of do all these things that are attending to the machine, but not really related to solving the problem at hand. Just one example, a variety of other ways in which it may be appropriate to modulate the degree to which I'm involved or engaged with the automated system. So to give you a quick example here, we're gonna dip into healthcare once again. The idea here is to design a warning about medical imaging, or physicians are ordering medical imaging, and we want to be able to flag or warn clinicians when that imaging may be inappropriate or when there may be a more appropriate form of imaging available. So here's design A. This is kind of a text-based pop-up, but there's a really clear indicator that this machine has flagged that there's a more appropriate imaging test that might be available here. Alternatively, we have a more visual-based display that's like sort of less assertive, maybe a little less clear in what the machine is quote unquote recommending here, but a visual-based representation of kind of the various options that a physician might have for ordering imaging. All right, so I'll pick on usability heuristics once again, really briefly here. There are two of them. I want to focus on. So usability heuristics emphasize that design should be minimalist. They shouldn't include a bunch of extra stuff if it's not needed. And usability heuristics emphasize that design should help people recognize, diagnose, and recover from errors, and even kind of provide explicit solutions when errors arise. And so if we use these usability heuristics, it's pretty clear that this first design, this textual-based design, seems to align with these usability heuristics better than this one on the right-hand side. It's only shown, it only pops up when it's needed. Otherwise, it's kind of invisible or in the background. And there's a very clear warning with a clear solution. This other one might be perceived as more ambiguous or competes for attention. But our joint activity design heuristics actually kind of flip the script here. If we use our one of our heuristics, this design on the left-hand side, textual-based design that pops up, is certainly more disruptive. It's an interjection into workflow. It's more disruptive, and it's a more machine-driven involvement or engagement with the machine rather than a design that allows people to more fluidly modulate their participation here. But who cares about heuristics? How do these designs actually perform? Which is actually, or what are the benefits and costs of these designs when people actually use them? And what we found is that actually with this design on the left, when the machine offered a recommendation that was incorrect and in fact dangerous in a situation, surprisingly 50% of clinicians accepted the machine's dangerous solution. With this design on the right, actually only 10% of clinicians accepted this dangerous solution. So it's pretty clear that the kind of more visual joint activity based design seemed to be less susceptible. The joint human machine system seemed to be less susceptible to erroneous machine recommendations with the joint activity designed solution. All right, just checking time real quick. I think I'm doing pretty good to get through the rest of these here. We have a couple more groupings of heuristics. One of them is joint perspective shifting. So heuristic number 8, we believe design should organize but not reduce data to reveal both the big picture and the kind of individual granular details of a display simultaneously. And number 9, design should be or interfaces should be designed to allow for fluid shifting across multiple different perspectives, to enable to kind of extract and integrate that information across different perspectives or conceptual spaces. Quick example of that, again, we'll dip into the medical sphere. That's where we have a lot of our designs. Right here, you're looking at that same, or a further iteration of the same display, the same nurse display that we showed earlier. Now, this display has a variety of different data sources that, frankly, are too many to probably fit on one screen. And so the standard way of kind of switching between views might be to have something like a hamburger menu. We've all been conditioned, we know, to click on that hamburger menu to see a variety of options. And maybe I switch options from here. But the question is, how do I know what to click on and when? So even if I was lucky enough to view kind of the right data source and when, how do I know when there's something outside my current view, my current perspective, my current view of what I'm looking at? How do I know when there's something outside of that view that I need to look at? And so here's a quick example. Actually, this is real patient data. If we're looking at this window right now, right now we're showing 4 hours of data in this window. I'm certainly no nurse, but I look at this and say, over this 4-hour span, it looks like this patient's heart rate and respiratory rate have remained, the respiratory rate's a little bit noisy here, but it's remained fairly constant throughout this 4-hour window. Maybe I'm feeling pretty good about the patient and where they're sitting at. Oh, there we go. Oh, okay. So patient looks stable. Sorry, I jumped my own I jumped my own gun here. Patient looks stable here. Let's add, though, a little bit more explicit support for shifting perspectives here. This technique on the side, we can debate to what degree this is a good example, but this is an example of providing kind of a long shot, a general overview, a high level overview of what data sources we have available and kind of what's happening in each of these data sources. So we have these kind of miniature graphs here. And what we can see from these miniature graphs is that although it does look, there seems to be over a wider span of data, it actually looks like there seems to be maybe a slight upward trend in heart rate and respiratory rate that's occurring outside of the current window of data that I'm looking at. And indeed, if we kind of expand our window here, we can see that trend more clearly. But notice that it kind of took this extra support to help me understand where and when I should be looking. And in fact, this is a patient case that's pretty hard to recognize because there's a very slow creep of data over a very, very long span of time. And this is actually a patient who is trending towards needing an emergency intervention. So this is an early signal of deterioration with the patient. Final grouping of heuristics here. We actually have several in this grouping here related to supporting human-machine coordination. I'm going to go through them really quickly in the interest of time here. First is including global explanations for machine decision-making. These are things like, how does the machine generally work? What are its general rules, quote-unquote rules for making decisions? What situations does it work well in? What situations does it work poorly in? Kind of the general stuff that you would want to know about working with a machine. However, we also need to provide local explanations for machine decision-making. So not just the general stuff, but actually, how is this machine working right now for this particular situation that I'm dealing with? Few more here. Again, maybe obvious to this audience, but certainly worth stating. The display should make it clear the kind of system modes that the automation or machine can be in and when it changes modes, and especially under what circumstances does the machine change modes. Certainly, again, maybe obvious here, but certainly the automation behavior should be predictable. We should be able to reasonably expect what the automation will do next at any point in time. And the one I want to emphasize the most here is that one of our heuristics that we've developed is that automated systems or displays should be able to convey when machines or systems are experiencing anomalies or might be misaligned to situations, even when the machine itself doesn't, quote unquote, know that it's misaligned to a situation. So this is, we call this machine fitness assessment, the ability to understand and recognize when the machine doesn't have, the machine's model of the world is misaligned to the actual world itself. And so I want to give one example here. This is that same patient display that we've been looking at before. Now we're going to stick a machine recommendation on top of it here. So this is an AI algorithm that's trained to predict the probability of this patient needing an emergency event in the next 5 minutes. And it's pretty, it might go without saying that when we just stick an AI prediction on here, it's pretty hard to tell when that AI prediction might be right or wrong. And so and obviously when that machine is wrong, it could be harmful to human machine performance. And so there's been a lot of research and in development in how to develop explainable AI or explainable AI techniques. And we tested one of them. This is actually these red annotations that you're seeing here are a visual explanation of the outputs of this AI model. And so, on paper at least, it's like, great, we have a model, we have an explanation. People, I would expect people should be able to use this explanation to recognize when that machine is right and wrong. But what we actually found is that even with these explanations on the screen, our nurses were still substantially influenced by this AI recommendation. And in fact, sometimes when we just had these visual explanations on the screen, they were also influenced by those, both helpfully and harmfully. So this arc, just because we have an explanation of the AI algorithm on the screen, doesn't necessarily fully support people in understanding when and how and in what situations that AI might be misaligned to the situation. And we certainly don't have the time to get into detail on all this, but I only put this slide up to say that there are other potential human-machine architectures that we could explore beyond this kind of standard architecture of machine offers recommendation and an explanation, and then a person kind of figures out what to do with it. There are other architectures. One, for example, is a critiquing architecture. So this machine, rather than offering a recommendation that a person either accepts or rejects, this machine instead is kind of monitoring how the person is doing their work and offering sort of helpful critiques along the way of common pitfalls. And some research has suggested that this architecture may be less susceptible when the machine is wrong. And again, a variety of different architectures we could talk about, but not in the next 7 minutes or so. So in wrapping up really quickly here, we feel the need to sort of we feel the need to fill this gap of heuristics. This landscape of analysis, guidelines, patterns, and even we haven't talked anything about testing and evaluation methodologies. Certainly, this landscape that we're presenting is incomplete here. But we feel that there's a great need for heuristics to help us bridge between guidelines and patterns and help us both design more resilient technologies or human machine systems that are more resilient, especially to machine errors. Heuristics to help us design more resilient human machine systems. And Mike, please interject any last things before we turn it over to questions here.
Yeah, just one other thing, and that is that whereas it looks like the guide, there's enough guidelines to fill in there, enough patterns to fill in there. We want to make those much more robust as well. So we are actively looking at new design patterns that will operationalize the heuristics. We're looking at new guidelines to be those kind of abstract guideline signals, for the heuristics. So all of that design area is still quite ripe, as well as all of the evaluation stuff, which maybe the evaluation and joint activity testing, maybe that's for the next webinar. And then I also just wanted to, we have lots of references that we went through really quickly. Happy to send you a reference list, maybe even get an online version of this. And let's open it up for questions.
Sounds great. We have a number of questions in the chat. They all came in fast and furious, so some of them have yet to be answered. Let's go to John said, do you feel these heuristics could be crafted as guidance for operational test and evaluation of human AI teams?
So I mean, depending on what we mean by operational test and evaluation, we have actually outfitted this in a heuristic evaluation process and procedure that we've tested out at a number of places. We're going to continue testing that out. Very similar to how the usability heuristics have been done, as an analytic evaluation. We also, and maybe it's just because we design the heuristics and we design the joint activity testing method, there's lots of affinities for how we're thinking about what makes work difficult and how we're setting up our scenarios. So yes, we should expect that these heuristics should guide how we set up not only the analytic evaluation, which is more direct, but the empirical evaluation, which like that's the one that includes humans and stuff. So that we say, okay, yeah, I see a potential weakness here because it's not applying a given heuristic. We're going to go right after that one and see if indeed it gives people problems, because we're not going to be 100% sure, but we that's what we want to go test.
Okay, great. We also have a question here that says, some of your principles differ from modern commercial trends. Could you contrast them to recent design trends, for example, encouraging anthropomorphism and human-like multimodality in LLM UIs? Most of your examples are from a clinical setting. Should the same principles hold for more commercial or less sensitive applications?
So it depends on what your goal is. If your goal is that the LLM or the AI, the AI avatar is as influential as possible, then yes, embrace anthropomorphism, embrace making it as human-like as possible. That should not be your goal, though. Your goal should be that joint system working as well as it can together. And so, anthropomorphism, we're going to do it anyway. We anthropomorphize everything: squirrels, your pet, whatever. It's going to happen. When we do it more by design, then we start attributing all kinds of things to what that, and Dane talked about that like really briefly, but even we were surprised by how much people did it. And in our case, all to negative effect. So if your job is to sell stuff, sure, anthropomorphize it. I've done it in the past. But if your job is to support resilient, joint cognitive systems, then be very, 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 very skeptical and be very, very, very careful about that particular strategy. And I think that goes more broadly as well. That if your goal is to sell product, okay, fine, let's go sell product. But if your goal is to support human machine teaming, or what we talk about is joint human AI systems, then I would stick with us. If the result is the most important thing, then stick with us. Or stick with these. Even if you don't stick with us, stick with these.
Okay, we are coming up hard on time here, so I am going to close this off. Do either of you have any other closing thoughts before we end?
The one I'll close real quick, and that is every one of these sentences has a paragraph behind it, and every one of those paragraphs has somewhere in the published universe has at least 2 pages or 2 to 5 pages written by one of us on it, and each of those 5 pages, 2 to 5 pages, has multiple dissertations behind it. So trying to smash that into a sentence never worked. And it never worked for any of the design heuristics. So we need these, whatever we come up with, these labels, they need to be shared common grounding tools after you've read the thing. Then you're like, oh yeah, that's the minimum viable assertiveness, because now I know what they're talking about with assertiveness. We're never going to agree on the right word. So that's where really how we want to use these things is, please go dig in. There are a couple different things. We'll send out references if you have a hard time getting to them, and we'll keep sending them. We want you to read this stuff. This 55 minutes is never going to be enough. These slides are never going to be enough. And there's a ton of stuff behind it that we would love to share with you.
That sounds great. Thank you so much to both of you for sharing your expertise. A couple of questions about whether or not the slides and the recordings will be posted. We will post them on the Cecil website, which I have dropped into the chat. It's u.osu.edu/CSEL. Again, if you would like to sign up for our newsletter about what's happening within the lab and within the Resilience and Proactive Safety Initiative, I will drop the link into the chat as well. Thank you so much, Dr. Rayo and Dr. Morey, and cheers. Thank you to everyone who attended today.
Thanks, everybody. Thanks for coming out.
Thank you.